for this. So introduction of complex numbers. This is part 2. So how do we introduce what is Argand plane and what is polar plane? We'll see. Polar representation. So now we have already learned in the earlier classes what's a Cartesian plane. So whoever can remember, when we did in 10th class, we know what is Cartesian plane. So the first one which we are going to do here is what is Cartesian plane. We'll just see Cartesian plane. Then the second one which we are going to learn is called as Argand plane. So in Cartesian plane, it is nothing but the representation. You know what is x-axis and y-axis, isn't it? This is x-axis over here, this is y-axis, this is negative y-axis, and this is negative x-axis. So you know all positive values of x will be here, all negative values of x will be to the left hand side, all positive y values will be up on the vertical line, and down on this vertical line you will have all negative values. So then a representation of all real numbers is nothing but it is said to be a Cartesian plane. That means we represent all these real numbers. Suppose you are taking x and y, 1 and 2. If you are taking x and y, this can be represented on this Cartesian plane. Then you have suppose minus 2 and minus 3. You can represent this on the Cartesian plane. Now here in the Cartesian plane is again divided into 4 quadrants, that is first, second and third, fourth. So in this 4 quadrants, in the first quadrant you have both positive, x and y positive. Then in the second quadrant you have x negative and y positive. The third quadrant you have x negative, y negative. In the fourth quadrant you have x positive and y negative. So it is divided into this 4 quadrants in this way. Now this representation of all the quadrants and the whichever point you are going to represent, in which plane, in which quadrant it lies, that is nothing but the Cartesian plane. So now here real number 1 to where do we represent here? This is called as, this point it is 1, 2. So we represent this real number on the Cartesian plane. So now next, what is Argand plane? In Argand plane, what do we represent is complex numbers. You know that complex numbers consist of a real part and an imaginary part, isn't it? So now what is this real part? Now suppose if we take here z is equal to 3 plus 2i or something, we are taking some example. So now here real of z is equal to 3. This is nothing but it is represented on the x-axis, and imaginary part of z is equal to, from this you can see imaginary part is this, so it's equal to 2. This is represented on the y-axis. So now how do we represent this? We'll just see. So now whenever we are taking such type of points, now here x-axis we don't write it as x-axis, we write here as real axis. This is called as, the horizontal line is called as the real axis, the vertical line is called as the imaginary axis. Now representation of this complex number on this plane is called as an Argand plane, where we represent the horizontal line as real axis and the vertical line as imaginary axis. So now how do we represent this? Now this representation over here, you're having x-axis, this is the real value is 3 and the imaginary value is 3 and 2. So you can mark here and see 1 2 3 1 2 3. So this is 3 and 2 means here the point is. So this is called as representation of a complex number on the Argand plane. So now suppose if you are taking some example, some other example, suppose we take it as z is equal to minus 3 minus 2i, same value we are taking here as minus values. So now here real of z is what? Minus 3, that is the x-axis, and then imaginary You can write it even in this. And real also can be written as RE of Z. So imaginary we can write it in this of Z is nothing but equal to 2. This is represented on the y axis. So the point which we have to mark on the argand plane is -3, -2. So now this over here, how is this represented? This is 1, -1, -2, -3, and this is -1, -2, -3. So -3 comma -2 is somewhere over here the point is. So this is called as -3 comma -2, or this is also represented as the complex number -3 minus 2i. This is represented by the complex number 3 plus 2i or 2i eta. So these are the representation of complex number on these axis, that is real axis and imaginary axis, is called as the argand plane, and representation of real numbers on the plane is called as Cartesian plane. So now let's go into how to find what is the polar representation. To find out the distance from the origin to this given point, that is for a complex number, whatever is the point given, how to find out this distance. So now this can be written as, or even you can take from origin to this point. So here we use the formula r is equal to root of x square plus y square. So now here you can either take the negative value or the positive value. So here I have taken it as -1. So -3 whole square plus -2 whole square, which is equal to 9 plus 4, which is equal to root of 13. This is equal to root 13. Even from here to here also it is root 13, because you know that x square plus y square is nothing but again 3 square plus 2 square, which is equal to 9 plus 4 under root, which is equal to root 13. So now how to find out from the origin to that point on the argand plane the distance, origin to the given point, you have to use this r is equal to root of x square plus y square. Now how to represent a complex number in polar representation form, we'll just see. So now here we are having polar representation. So now if we take the axis over here if we are representing a point in the form of r comma theta, now from origin to this distance is called as r, this angle is called as theta. So this is the connection between this polar representation of r and theta. So whatever is the angle which is formed with the x axis is called as theta, and the distance from the origin to this point is called as r, and this is called as the polar representation of the given complex number. Resolution of vectors in your previous classes or in physics you must have learned. So over here, this according to that you can write this as r cos theta, and this perpendicular line is called as r sin theta. That is this. So now if you see that if this r is falling on this line, this distance from here to here is nothing but it is r. So here becomes theta becomes 0. So you know that cos theta is equal to 0 it becomes, because this r gets overlapped with this when it comes on to this point. So when r of cos 0, it's equal to r into 1, which is equal to r, and you know the distance from here to here it is equal to r. So r is equal to r. That's why we have taken this as r cos theta. And you also know that cos theta and sin theta, they don't take infinite values, they take only some real values. So because of that we have taken it as r cos theta and r sin theta. And now if we take this r onto this line, it becomes this angle, that is this whole angle, it forms 90 degrees. Now this whole angle is nothing but 90 degrees. So therefore you are getting r sin theta. Here theta is equal to nothing but 90 degrees. So r of sin 90 degrees, which is equal to r into 1, which is equal to r. So you are getting this distance from here to here, definitely if this line comes and overlaps with this is nothing but distance r. So therefore we are getting r is equal to r. So therefore that's why this is taken as r sin theta we are taking on y axis, and r cos theta we are taking it on on x axis. Now you cannot take this as here r sin theta or here r cos theta, because if you are taking here sin theta you will get sin 0, that is equal to 0, and this distance is not 0, isn't it? From here to here it is distance r. So therefore we are taking this as r cos theta and this as r sin theta. So that is the way we are going to use it. So I think now this, how did we get the polar representation we have seen. Now we'll represent with how a complex number can be represented in this polar representation form. We'll just see. So we'll just go into what is it. So we'll take some complex number and then we'll see how to represent it in the polar representation form. Now z is equal to x plus iy or iota y. So now this can be represented in polar representation, because here we are taking on x axis as r cos theta plus I, on y axis we have taken it as r sin theta. Now this is called as the polar representation. So therefore represent this in the form of x is equal to r cos theta and y is equal to r sin theta, that is the imaginary number. And we also know that if you take out r common inside, you can write this as cos theta plus I sin theta also. This can be written in this form also. And we also know that now r is equal to under root of x square plus y square. We have this formula because it's from the origin to the given point in the plane. So over here this distance is equal to nothing but root of x square plus y square. How did we get this? We'll just see. Now we know that taking this as equation 1 and this as equation 2, squaring and adding equation 1 and equation 2, we get x square is equal to r square cos square theta, y square is equal to r square sin square theta. This implies, now you know x square plus y square is equal to r square into cos square theta plus r square into sin square theta. So now if you take out r square common, you will get it as cos square theta plus sin square theta, and you know that r square cos square plus sin square is equal to nothing but 1. So this is equal to r square into 1. Therefore we got x square plus y square is equal to r square, which implies that r is equal to under root of x square plus y square. So we have proved this formula where the distance from the center to the given point in the plane. So this is the formula which we use, that is r is equal to root of x square plus y square. So we'll see how this polar representation of a complex number is done by taking with an example. So I will take some example and start doing it. So here example, z is equal to 1. So now here you know that z can be written as x plus iy. Here x is equal to 1, y is equal to root 3. So now the polar representation of z is equal to r cos theta plus I r sin theta. So therefore you are going to get it as, now you know that x is equal to r cos theta, y is equal to r sin theta. So you know what is x and y. So 1 is equal to r cos theta and here root 3 is equal to r sin theta. So therefore you are getting here. Now we have to first find out what is r. We know that r is equal to What is r equal to? R is equal to under root of x square plus y square, which is equal to r is equal to root of 1 square plus root 3 whole square, which is equal to root of 4, which is equal to 2. So therefore 1 is equal to 2 cos theta, root 3 is equal to 2 sin theta. So cos theta is equal to 1 by 2, and here you are having sin theta is equal to root 3 by 2. Now here we have a representation for alpha, and now suppose we are having this axis over here. We know that there is a point over here, this point is nothing. Here we are taking it as r and theta, isn't it? So now here this is theta and this is called as alpha over here. So now here alpha is nothing but it is equal to tan inverse of equal to root 3 by 1. So which is equal to alpha is equal to tan inverse of root 3 is nothing but tan of pi by 3. So these two will get cancelled. So therefore alpha is equal to pi by 3. So now here we have to see over here how do we take this alpha over here. What are the different values we are going to get for now. This is the first quadrant. You know that this is the first quadrant, second quadrant, third quadrant and fourth quadrant. So here we know that both are positive, that is x and y. Here x is negative and y is positive. Here both are negative. Then when it is in this fourth quadrant, it is positive and negative. So now when it is, how to find out alpha? Alpha is equal to, how do we get this? We'll just see. So here we have in the first quadrant theta is equal to alpha. Then in the second quadrant we have theta is equal to pi minus alpha. Then in the third quadrant theta is equal to minus of pi minus alpha. In the fourth quadrant we have theta is equal to minus alpha. So we know that what is the relationship between theta and alpha, because if the point is over here you have to use it as, it is in the third quadrant means we'll get it as minus of pi minus alpha. This is in the second quadrant when it lies, it is pi minus theta is equal to pi minus alpha. So after then in the fourth quadrant you will get it as pi theta is equal to minus alpha. Polar representation is what? R cos theta plus I sin theta. So therefore z is equal to, what is r we got? We got r is equal to 2, isn't it? Yeah. So we got 2 cos pi by 3 plus I 2 sin pi by 3. So now here because we are having both the quadrants are positive over here, you can see how did we take these values in the first quadrant, second quadrant, third quadrant and fourth quadrant. Because here in both the values which we have taken are 1 comma and root 3, both are positive. So therefore we can use this formula where theta is equal to alpha. So now what is 2 point? Now conjugate is nothing but represented as z bar. If you are taking some x plus iy, it is equal to x minus iy. This is called as the conjugate. That means in the place of plus you are putting it as minus. And modulus, how do we take it? We'll just see. So now for modulus, in the modulus part, you know that putting it, we write it in this way: mod z is equal to under root of x square plus y square. This is called as modulus. So this is the introduction of the second exercise. We'll just go into what is the exercise. Hello friends, let's start off with chapter 5, complex numbers and quadratic equations, exercise 5.2. So class 11. The first question over here you're having is find the modulus and the arguments of the following complex number. So what is given to us? First we'll see over here. So what is this question? It's given that solution. So we have to find out the modulus and arguments. So we know what is modulus of this. So what is given to us? Z is equal to minus 1 minus of I root 3 or iota root 3. Into modulus, Z is equal to minus 1 minus I root 3. So this is in the form of x plus iota y. So here x is equal to minus 1, y is equal to minus root 3. So here this is minus 1 and minus root 3. So now here if you are representing this on the Cartesian plane, this is actually represented on the Argand plane because it's a complex number. So therefore now you know that both x and y are both here in which quadrant. You can see both are negative. So therefore here you're having all negative values, isn't it, for x, and this is all positive values, this is all positive values of y, and this is negative values of y. So here this in this quadrant we are having this x and y because both are negative. So therefore z is equal to r cos theta plus I r sin theta. So mod of z is equal to r, which is equal to under root of x square plus y square, so which is equal to under root of minus 1 whole square. We know that x is equal to minus 1, y is equal to minus root 3. So this is equal to root of 1 plus 3, which is equal to root 4, which is equal to 2. So we have r is equal to 2, or modulus z is equal to, this is nothing but the modulus we found out still. Now we have to find out what are the arguments we have to find out. So now here when you are comparing this first equation, that is z is equal to minus 1 minus I root 3 with z is equal to r cos theta plus I r sin theta. So here you know that I have already introduced you all why do we take this as r sin theta and r cos theta. So here you are having x is equal to r cos theta and y is equal to r sin theta. So therefore here you are having x values, you are having y values, you are having. So we'll substitute over here. See, from here you are having x is equal to minus 1 and y is equal to minus root 3. So we'll just substitute, and we also got r is equal to 2. So therefore we got this as 2 cos theta is equal to, here you can write this as minus 1. So we are, and also we are having sin theta is equal to 2 sin theta is equal to minus root 3, or here you are having cos theta is equal to minus 1 by 2 and your sin theta is equal to minus root 3 by 2. So we got these two values over here for cos theta and sin theta over here. So now how to find out what is the arguments, we'll see. So we'll have to find out what is alpha. So alpha is equal to tan inverse of mod of y by x, which is equal to alpha is equal to tan inverse of minus root 3 by minus 1. So which is equal to tan inverse of, and here root 3, where do we get root 3? We get it as tan of pi by 3. So here tan of pi by 3. So therefore these two will get cancelled, which is equal to pi by 3. So that is alpha is equal to pi by 3. Now we know that in third quadrant we have already seen these formulas. In the third quadrant, theta is equal to minus of pi by 3 So theta is equal to minus of 2 pi by 3. So therefore you are getting a theta is equal to minus 2 pi by 3. So this is the argument which we are having. So this is the way we will be writing this value. So here you are getting here in the third quadrant alpha is equal to pi by 3. With this pi by 3 we have to find out what is theta, and you know that because it lies in the third quadrant, I have already explained here theta is equal to minus of pi minus pi by 3. So this is called as argument, and this is the modulus which I have written here. So this to be formed. So now next we'll go into the second question. So in this second question you have that find the modulus and arguments of the following complex number. So z is equal to minus root 3 plus I or iota. So solution. So z is equal to minus root 3 plus I. So now how to do this problem, we'll just see. We can now compare, we'll find out first what is the modulus. So you know modulus z is equal to x plus iy. So here you having x is equal to minus root 3 and y is equal to 1. So now what is modulus you are getting? So mod of z is equal to r, which is equal to under root of x square plus y square, which is equal to root of minus root 3 whole square plus 1 square. So which is equal to root of 3 plus 1, which is equal to root 4, which is equal to 2. So therefore you have got mod z is equal to r is equal to 2. So now we know that this is in which quadrant does it like. So this we have to always put which, because here you are having x is negative and y is positive. So in which quadrant? It is in the second quadrant. X is negative. You can see from here that x is negative and y is positive. So you can take it from this. So it lies in the second quadrant. So here how do we get theta in this? You will get it as pi minus alpha. We have seen this. This is the argument. So alpha is equal to tan inverse of mod of y by x, which is equal to alpha is equal to tan inverse of minus root 3. Y is 1 divided by minus root 3. So this is alpha is equal to tan inverse of mod of 1 by root 3, which is equal to tan inverse of, so tan of pi by 6. So this will get cancelled. So you're getting it as pi by 6. So now what is theta equal to? Theta is, it lies in the second quadrant. So in the second quadrant, so theta is equal to pi minus of alpha, which is equal to pi minus of pi by 6, which is equal to 6 pi minus pi by 6, which is equal to 5 pi by 6. So theta is equal to 5 pi by 6 is the argument. And we got mod of z is equal to 2. Theta is equal to 5 pi by 6. This is the modulus and this is the argument. So now going into the next problem. Convert the following complex numbers in the polar form. So how do we do this? We'll see. What's the solution of this? So given here you are 1 minus I is given. So this is nothing but it's a complex number. Z is equal to 1 minus I. Then we have to compare this with x plus iy. Always compare it with the general form. So here x is equal to 1, y is equal to minus 1. So then polar representation is z is equal to r cos theta plus ir sin theta. So now when we are comparing it with the general form x plus iy, the complex number, so here we are having r cos theta is equal to x, r sin theta is equal to y. So now we know what is x and what is I. Now y. So now before that we'll remove what is r, which is equal to root of x square plus y square, which is equal to under root of 1 square plus minus 1 whole square, which is equal to root of 2. So this is equal to r is equal to root 2. So now we have that r cos theta is equal to x, r sin theta is equal to y. So here r is root 2 cos theta is equal to 1 and root 2 sin theta is equal to minus 1. So cos theta is equal to 1 by root 2, sin theta is equal to minus 1 by root 2. So now here how to find out theta. So now we know that alpha is equal to tan inverse of mod of y by x, which is equal to tan inverse of minus 1 by 1, which is equal to tan inverse of mod, so it is 1. So which is equal to tan inverse of tan pi by 4. So it is here tan pi by 4 is 1. So tan will get, tan inverse and tan will get cancelled. So which is equal to pi by 4. So alpha is equal to pi by 4. Now we have here, now we have to see that where x is equal to 1 and y is equal to minus 1. So here in the fourth quadrant we have x is positive and y is negative. So now we have to find out the value of theta in the fourth quadrant. So in the fourth quadrant we have theta is equal to minus alpha, which is equal to minus pi by 4. So now we have to substitute it in this polar representation form, that is z is equal to r cos theta plus ir sin theta. So which is equal to root 2 cos of minus pi by 4 plus I root 2 into sine of minus pi by 4. So this is the polar representation of is the polar representation of 1 minus I. If you want, you can take out even test z is equal to root 2 into cos of minus pi by 4 plus I sin minus pi by 4. So this is the answer. Now next, this we have solution for the fourth question. In this we have z is equal to minus 1 plus iota or I. So z is equal to x plus iy. So here we are going to compare x is equal to minus 1, y is equal to 1. So now you know that z is equal to r cos theta plus iota sin theta is nothing but the polar representation of the, it's in the polar representation form. So now we have to find out what is r, what is theta. So here you know that r cos theta is equal to x, r sin theta is equal to y. So therefore you will get here r cos theta is equal to minus 1, r sin theta is equal to 1. So before we'll find out what is r. R is equal to nothing but root of x square plus y square. So r is equal to root of minus 1 whole square plus 1 square, which is equal to 1 plus 1, which is equal to root 2. So therefore we got r is equal to root 2. So cos theta is equal to minus 1 by root 2 and sin theta is equal to 1 by root 2. Now we have to find out what is theta. So before finding out theta, we have to find out what is alpha. So which is equal to tan inverse of y by x, mod of y by x, which is equal to tan inverse of what is y. Y is 1 by minus 1. So which is equal to tan inverse of mod of minus 1, and mod of minus 1 is nothing but equal to tan inverse of 1, which is equal to tan inverse of tan pi by 4. So just cancel this. So you're going to get alpha is equal to pi by 4. So we got what is pi by 4 we got. So now we have this in this, which quadrant we have to find out this theta is in. We'll just see that. So because x is negative and y is positive, it lies in the second quadrant. So since x is negative and y is positive, to find out theta, we'll see theta is in the second quadrant. So therefore in the second quadrant, theta is equal to pi minus alpha. So which implies theta is equal to pi minus of pi by 4. So LCM is 4, means 4 pi minus pi. So theta is equal to 3 pi by 4. So polar representation z is equal to r cos theta plus I r sin theta. So therefore z is equal to root 2 cos of 3 pi by 4 plus I root 2 sin 3 pi by 4. So if you remove root 2 common, this is nothing but cos 3 pi by 4 plus I sin 3 pi by 4. So this is the answer, and this is the polar representation of minus 1 plus I. In this solution of question 5 is, now you are having this z is equal to minus 1 minus I. Compare it with the general form x plus iy. So x is equal to minus 1, y is equal to minus 1. So therefore you are having that x and y values we got here. So now we can find out what is the polar representation form. We can write z is equal to r cos theta plus I r sin theta. So therefore now you can write this one here, r is equal to under root of x square plus y square. So it's equal to under root of minus 1 whole square plus minus 1 whole square, which is equal to root of 1 plus 1, which is equal to root 2. So here we got what is r is equal to root 2 we got. Now you know that r cos theta is equal to x, r sin theta is equal to y. So now you can substitute here. You got here root 2 cos theta is equal to minus 1. Here root 2 sin theta is equal to minus 1. So therefore cos theta is equal to minus 1 by root 2. Sin theta is equal to minus 1 by root 2. So now we have to find out now what is the value of theta. So in order to find the value of theta, now you know that we all know that here, since when we are taking this line here, you are getting this as it's lying in which quadrant, we can see both are negative. So it definitely lies in the third quadrant. So in the third quadrant we have both negative, means we are getting this equal to minus of pi minus alpha. So therefore here you are going to write it as r is equal to, we got root 2, so therefore alpha we find out first. So tan inverse of mod of y by x, so which is equal to tan inverse of minus 1 by minus 1, which is equal to tan inverse of 1 mod of 1, that is equal to tan inverse of tan of pi by 4. So with this tan and this tan inverse will get cancelled, so you're getting alpha is equal to pi by 4. So now how do we find out theta? Theta is equal to minus of my pi minus pi by 4, so which is equal to minus 4 pi minus pi by 4, which is equal to minus 3 pi by 4. So we got theta is equal to minus 3 pi by 4. So now we will put it in the polar form, that is r is equal to z is equal to r cos theta plus I r sin theta. We know all the values, so therefore this is root 2 cos of minus 3 pi by 4 plus I into root 2 sin minus 3 pi by 4. So this is z is equal to, which is equal to, if you take out root 2 common, you're getting cos of minus 3 pi by 4 plus I into sin minus 3 pi by 4 is the answer. Is the polar representation of, is the polar representation of minus 1 minus I. So this is how we got the fifth one. Now we'll go here, we do not give the, so now here this solution. So now here you are given that z is equal to minus 3, so you can write this as iota 0 or 0 iota as, compare it with the general form x plus iy. So therefore you are getting x is equal to minus 3, y is equal to 0. So now polar form is z is equal to r cos theta plus I r sin theta. So we are having r cos theta is equal to x and r sin theta is equal to y. So now we are having r cos theta is equal to minus 3, r sin theta is equal to 0. So now here you have, we'll find out what is r. So r is equal to under root of x square plus y square. So r is equal to under root of minus 3 whole square plus 0 square, so which is equal to root of 9. So therefore r is equal to 3. So we got here 3 cos theta is equal to minus 3, 3 sin theta is equal to 0. So therefore cos theta is equal to minus 3 by 3. So sin theta is equal to 0 by 3. So cos theta is equal to minus 1, sin theta is equal to 0. So we got this sin theta, sin theta is equal to 0 we got. So now here you can see this is, now this is on x axis it lies. Now we have to find out, what is the value of theta. So we are this, in this problem we have that it lies on the x axis, that is on the negative axis. So if you take this as minus 1, minus 2, minus 3, it lies on this point, that is minus 3, 0. Now we have to see that angle where we are going to get this cos theta is equal to -1 and sin theta is equal to 0. So now we'll just see over here, alpha is equal to tan inverse of mod of y by x, which is equal to tan inverse of 0 by -3. So this is equal to tan inverse of 0 so alpha is equal, so tan inverse of now where do we get 0? Tan 0. So therefore alpha is equal to 0. So now how do we remove theta now? So now we'll see this theta. So you can take it in the second quadrant. So therefore theta is equal to, theta lies in the second quadrant, and in the second quadrant theta is equal to pi minus alpha. So theta is equal to pi minus of 0. So which implies that theta is equal nothing but pi. So therefore our argument over here in the polar form, z is equal to r cos theta plus I r sin theta. So therefore z is equal to 3 cos pi plus I3 sin pi. So therefore this is equal to 3 into cos pi plus I sin pi. This is the answer. This is the polar representation of question number 7. We'll see now. Convert the following complex number in polar form. So here you can see that this can be written as, so for solution of this, z is equal to root 3 plus I. So z is equal to x plus iy. So comparing this, x is equal to root 3, y is equal to 1. So polar representation of this is given in the form r cos theta plus I r sin theta. So therefore here you have to, we know that x is equal to r sin theta and y is equal to r cos theta. This is equal to x is equal to r cos theta, y is equal to r sin theta. So first we'll find out what is r. R is equal to root of x square plus y square, which is equal to root of root 3 whole square plus 1 square, taking x and y from this, so which is equal to root of 4, which is equal to 2. So r is equal to 2 we got now. So now we'll substitute over here. Now you know what is this. So 2 cos theta is equal to root 3. So cos theta is equal to root 3 by 2. And here y is 1 is equal to 2 sin theta. So sin theta is equal to half. So now we have to find out what is theta value, in which quadrant does it lie. First we have to see, because then we'll find out what is alpha and then we can do this. So now here, this given from the problem, you can see that both of them here, both are positive, x and y. So it lies in the first quadrant. x is positive, y is positive, so it lies in the first quadrant. So therefore you can write this as tan of alpha is equal to tan inverse of mod of y by x, which is equal to tan inverse of 1 by root 3, so which is equal to tan inverse of pi by 6. So tan and tan inverse will get cancelled, so you're getting alpha is equal to pi by 6. So in the first quadrant, since both are positive, you get that alpha is equal to, since theta lies in the first quadrant, theta is equal to alpha. So therefore you're getting theta is equal to pi by 6, which because alpha is equal to pi by 6. So now we'll write down what is the polar form. Z is equal to r cos theta plus ir sin theta, so which is equal to r is how much, 2. So you're getting 2 cos of pi by 6 plus I2 sin pi by 6, so which is equal to, if you take 2, so cos pi by 6 plus I sin pi by 6 is the polar representation of root 3 plus I. So this is the polar representation of this. Now going into the next, how do we represent this in polar form, they are asking. So solution for this is, first we'll write down what is z given as. It can be written as 0 plus iota, because I only is given, only the imaginary number. You can compare it with the general form, so that is equal to, x is equal to 0, y is equal to 1. Now what is the polar form which we are having? Z is equal to r cos theta plus ir sin theta. That means we are having x is equal to r cos theta and y is equal to r sin theta. We'll find out what is r first. R is equal to root of x square plus y square, which is equal to root of 0 square plus 1 square, which is equal to root of 1, which is equal to 1. So r is equal to 1 for us over here. So we know what is here, x and y. So therefore 1 into cos theta is equal to 0, because x is 0. So cos theta is equal to 0. Then we are having 1 into sin theta is equal to 1. So sin theta is equal to 1. So now we have here, we have to find out what is alpha. Now you know that both of them lie in the first quadrant, because both are positive, 0 and 1. It's somewhere lying over here. So 0 and 1, it's in the first quadrant, both are positive. So therefore we have this as equal to, theta is equal to alpha in this case. So now we know that alpha is equal to tan inverse of mod of pi by x, which implies equal to tan inverse of 0 by 1 by 0. So 1 by 0, which is equal to, alpha is equal to tan inverse of, this is infinity. So tan inverse of infinity, where do we get infinity? So which angle where cos theta is equal to 0 and sin theta is equal to 1? So it is in 90. So therefore alpha is equal to tan inverse of tan pi by 2. So which is equal to pi by 2. So alpha is equal to pi by 2. So therefore since theta lies in the first quadrant, so theta is equal to alpha, therefore theta is equal to pi by 2. So therefore the polar representation is z is equal to r cos theta plus I r sin theta. So we are having here r is 1, so it becomes cos pi by 2 plus I sin pi by 2. So this is the polar representation of I or iota. So this is the last problem.